So for this question, we got a bunch of them here. So I'm just going to dive in. We're going to do them kind of all at once here. So for the first one here, notice I've got 6 root 2 plus 2 root 5 minus 8 root 5 plus root 2. Basically, I don't know what the square root of 2 is. It's an infinite decimal. I don't know what the square root of 5 is. It's an infinite decimal. So what I've got here is it's kind of like I've got 6 of these root 2's, and then over on the back end, I'm going to add another root 2. Well, how many root 2's is it? Well, that's 7 root 2's altogether. I've got 2 root 5's, and I'm going to take away from that 8 root 5's. Well, if I've got 2 and I take away 8 of them, it's going to leave me with a deficit of 6. So it's going to be minus 6 root 5. And so that's the answer. And I can't combine those two because the unknowns there, the root 2 and the root 5, those are different. Okay, those are different numbers, and I don't really know what they are. So I'm kind of treating these radicals as if they're variables. So look at the next one here. I've got 4 times the square root of 3x. Well, what I'm looking for now is another square root of 3x. So I've got that term there. I've got that term there. So I've got 4 of them in the first term and just 1 of them in that second term. That's 5 root 3x's total. Now I look at the next one. I've got this root 2. Well, I've got another root 2 term over here. I've got negative 4 of them in the first term where I see it, and I'm subtracting 1. So it's going to be negative 5 root 2's total. Now for this next one here, I kind of have to simplify this first. So I've got to look at 20. That's going to be 4 times 5d. And root 45 is going to be 9 times 5d. So I can pull out the square root of 4 there, and that's going to be 2. So I'm going to have 3 times 2 times the square root of 5d. And then in the second one, I can pull out a square root of 9, which is 3. So it's going to be 5 times 3 root 5d. So let's just take a look at that. That's 6 root 5d's plus 15 root 5d's. Oops, sorry, that's a 5d. I got a 59 there. 5d. Well, altogether, that's 21 root 5d. I've got to do something similar in d here. 5 root 3 is okay. But root 12, now 12 is the same as 4 times 3. And so 4 is a perfect square. That's awesome. Root 48. 48 is 16 times 3, so 16 is a nice big perfect square. And 75 is 25 times 3, and 25 is also a nice big square there. So this is going to become 5 root 3, and then the second one, that 4 root 3, I can take out the square root of 4, which will be 2 root 3. The next one, I can take out the square root of 16, which is 4 root 3. And then the square root of 25 is 5, but there's a 2 out front. So it's going to be a positive 10 root 3. Now, how many root 3's do I have total? Well, I've got 5 root 3's and 2 root 3's. That's 7 root 3's. Minus 4 root 3's is going to be 3 root 3's. Plus 10 more root 3's will give me 13 root 3's at the end there. For this next one, we've got 3 root x. Minus minus the square root of 4x plus root x. Well, that square root of 4x, I've got that square root of 4 in there. I can take that out, and it becomes 2 root x plus root x. And now they're basically all the same. 3 root x's minus 2 root x's is 1 root x. Plus another root x is going to give me 2 root x's. And then finally, for this last one here, 11y, there's 11 is prime. There's going to be no nice factor there. But 44 is going to have a factor of 4, and that will leave me with 11y there. So I kind of like that. So it's going to be the square root of 11y minus, and I can take the square root of that 4 to bring that out, that 2, 11y, square root of 11y. So 1 root 11y minus 2 root 11y's will be negative 1 root 11y. And that's the answer that I'm looking for.